So I'm back, and as you're looking at this problem, if you're in period 1, you can just fast forward and jump to the next one. If you're in period 3, 4, you probably want to take your time and do this one. Capacity is asking for volume. So volume's a pretty easy one to find in this case because I gave you this triangle where you've got a base edge and you've got a height of this triangle. Of course, the height of the prism is not 4. The height of the prism, as we all know, is 7, because that's the distance between the two bases. It's a triangular prism. I had some people calling it a pyramid yesterday, which of course it's not a pyramid. It's a prism. So you find the area of the base and you multiply it by the height. The area of this triangle, of course, is 6 times 4, which is 24, and then divide it by 2 because it's a triangle. So you get 12, and then take this 12 for that area and multiply it by 7. 12 times 7 is 84. You get 84 cubic feet. These would be units in feet. This tent is a 2-man tent, 7 foot by 6 foot by 4 foot tall. So there's the capacity. When you go to the second part of this, finding the canvas, that's the amount of material to build this thing. That's surface area. So most of these surfaces are easy to get. The front one and the back one, we already got those. Those are each 12 square units. That's just area of a triangle and area of a triangle. The bottom is easy to get. It's 7 by 6. The bottom is 42. It's the two slanted ones that are a little tricky to get. This is 7 by some length here. To get that one, you'll have to use some Pythagorean theorem or Pythagorean triples. And remember that, this is 6. We're going to cut it in half. This is 3 by 4. 3 squared plus 4 squared is equal to 5 squared if you do some Pythagorean theorem to find these two little lengths here. So there's my volume I talked about before if you want to just take a look at that if you didn't already do that one. The slanted edges, of course, are going to be 5 units long because it's a 3, 4, 5 triangle, which means this little this little slanted rectangle is 35 square units. And the same thing with the one on the right. It's 35 square units. You might want to ignore this. This is a formula that I didn't really cover. The lateral area, forget it. Lateral area is just adding up the 3 rectangles, the 35 plus the 35 plus the 42 on the bottom. Ignore that formula. It's a formula we didn't use. We made it a little simpler on ourselves. But you should get 112. 35 plus 35 plus 42 is 112. And if we add the two bases onto that, we get 136 square feet. If we add the 12 square units here and the 12 square units in the back, 24 plus 12, 112 is 136. And then to figure out the cost, you just multiply by 0.06. So it costs about $8, $8.16. The problem I wanted to get to was this cheesy example, and neither class got all the way through it. I was hoping one of the classes would get through it. I had to apologize. Some people didn't like my Chuck E. Cheese drawing. Sorry about that. The part of the drawing that I didn't like is not Swiss cheese. There's no holes in it. Assume it's a solid block of cheese. It does say in there, if you read, it's a 6 by 8 triangle. And what I mean by that is, I should have maybe drawn a right triangular prism here. This is 6, and this edge is 8. And there's a right angle there, so you'd have to use Pythagorean theorem to find this side length. This is definitely a tricky problem, and you have to understand the formulas and some algebra to get through this thing. So the question says find the volume. But I give you the surface area. So you know how to find volume. Volume is you find the area of the base, find the area of the triangle, and you multiply by the height. And one of the classes quickly realized, well, we don't have the height. Very quickly figured that out. We need to find the height. We need to find h. I would call that h and set up some sort of formula on here. So I give you the surface area. Because I give you the surface area, you can go and solve for h, and you can set up an equation. In other words, you can find the area of the top triangle. That's 6 by 8, and then divide by 2. So 6 times 8 is 48, divided by 2, this is 24. The bottom would also be 24. The front of this is just going to be 8 times h, whatever that is. The right side, looking this way, would be 6 times h, or 6h. And then the back one, which you can't see here, is whatever this hypotenuse is, times h. So you have 3 rectangles, and then the 2 triangles added up. Well, this hypotenuse, if you know your triples, this is a 6, 8, 10 Pythagorean triple on here. And of course, you could use Pythagorean theorem to get it. And it eventually gets you to some sort of equation here where you're given the surface area of 216. You know the area of one of the bases. You can double that because there's a top and a bottom. And then these are the 3 rectangles that I'm talking about. This is the front rectangle. There's the rectangle area on the right. And there's the rectangle area in the back. It's a 6, 8, 10 triangle. So you've got this algebraic equation, which is really not too bad to solve. And eventually you can get h out of this, and then you can go to your volume equation and plug in to find, the total volume of this thing. So of course we said the front and the back are both 24. Double that, you can get 48. Combine the areas of the three rectangles and you get 24h. That's a pretty easy equation to go and solve. You subtract 48 from both sides and you get 168 equals 24h, and it happens to be an integer. I picked some friendly numbers on there. Height ends up being 7. So if you're able to figure that on your own, very well done. That's a tricky problem in my opinion. So now you've got the height, and we already got the base area. The base area was 24. 24 times 7, you can get the volume. I believe it's also, and this is just a coincidence that it happens to be similar to this 168 up here. No connection between those two. That's actually the lateral area. So 168 cubic centimeters for the volume. Tricky problem for I'd say for 90% of the students. You really got to think about all the different steps in that problem, because you're going forwards and backwards sort of in one problem, and there's an algebraic part to it. I wanted to take this block of cheese now, and Chuck E. Cheese is hanging out looking at his aquarium, and he drops that block of cheese into the water. And many of you know what's going to happen. If he drops this block of cheese into the water, what's going to happen to the water? Well, of course, the water's going to rise. So the water level would rise by some small amount. And the question is, will it overflow this little 1 centimeter gap we have in the top? So it's a prism, 30 centimeters long, 15 centimeters deep, and it's 15 centimeters high. So the water is 14 centimeters deep, and we've got a little 1 centimeter gap on there. In other words, this is a square face over here, 15 by 15, if you look at the water level plus the 1 inch or 1 centimeter gap on there. So if Chuck E. Cheese accidentally drops the block of cheese into the aquarium, how much will the water rise, and then will it overflow? So think about what the heck that question's even asking. Is it asking about a volume, or is it asking about surface area? And many of you realize, oh, it's volume. Volume is being displaced. So you want to think of sort of an imaginary rectangle up here and compare it to the volume of this cheese. And we're going to steal the volume of the cheese from before. We're keeping this 168 for that volume. We're using that again. So the volume of the cheese is 168. The volume of displacement is a little prism on top of the actual water on there. It's the area of this rectangle times this height we're trying to figure out. And of course the area of that top rectangle is 30 by 15. The volume of the displacement is equal to whatever we dropped in there. It's equal to the cheese we just dropped in there. So you're trying to solve for the height. And it's basically just taking the shape of this cheese and pretending it's now this long rectangular shape of a rectangular prism to fill up this water level. You divide that. I'm not sure if I got this right because I changed the numbers from what I did on this problem last year. I think it's less than a centimeter. It's 0.373, which means it would not overflow, which is what the question was really getting at. How close coming to overflow would it be? And it's not even quite half of a centimeter, a little more than half a centimeter away. So what a relief. It did not overflow. You don't need to do this one. I'm going to leave this one off. You're not going to see one exactly like this, I don't think, on the exam. So leave off the last two. You can cross off the last two. You don't have to worry about them. I am going to add on one more thing, a review of pyramids. So tune in to one more little section. I got a review of pyramids. It's going to be part 3 here, coming up in a minute.